Good afternoon, everyone, one and all who is present here right now. And as in the classes, we have just gone through this chapter, as you can see here, refraction of light. Okay. Did you remember that we have just gone live in the chapter reflection of light, both with the part of the light of chapter of standard 10. Even you have studied in standard 8 also few of the students, so you can understand the things, you can understand the topics. Here we are going to go for the revise of all the topics which we have studied. Okay, and after understanding each and every topic, we are going to have a numerical questions. So there is a humble request to each and every student that kindly share this video to your friends, so everybody can come live, those who are in contact of you, and they can get benefit of education which I have just thought to provide free of cost in your life. Got it? I'm waiting for a few seconds. Let me see how many of you are just going to get joined here. So, good afternoon, everyone. In this today's class, we are going to have a quick revision of refraction of light, because as I have told you earlier only that what happened actually during the refraction of light, the speed of light is going to be changed when it is traveling from one medium to the another medium, and it is going to get bent also. Light is going to be get bent. Okay, suppose this is our atmosphere, and light is going to be travel from the atmosphere, and it is going to be enter into any kind of the transparent medium. That transparent medium is either, it can be water, it can be any kind of the glass, or it can be any medium where the speed of light is going to get changed. Now these two medium are taken as two different kind of the word which I have told you, if you have remember. One is the rarer medium, okay, and another one is known as denser medium. We can denote it by D, or we can write here denser. Why it is denser? Because it is a glass medium, or you can say any liquid medium. So that is more denser in comparison to the gaseous medium. Gases have less density in comparison to the liquid and in comparison to the solid. That's why actually what happens is, students, whenever light is going to be entered from the rarer to denser medium, किसी भी rarer medium से denser medium में जब light enter करेंगे, then the speed of light is going to get changed. Okay, and due to the change in speed of light, the light is going to be bent towards the normal. अगर हम लोग यहाँ पे एक normal line draw करें, okay, one imaginary line which we cannot see actually, but if it is a normal is perpendicular to this surface, you can see perpendicular to this surface, then the light rays which were coming with few speed, with velocity, they are just going to be get changed, and they are going to be divert toward the normal. Okay, वो क्या होगा, bend होगा, किधर bend होगा, towards the normal. It's not going to become directly, okay, like how it was just coming. The path of the light was this, but it is going to be get, okay, bent towards the normal. But what happens so when the question will come from your heart, that what happens so when the light is going to move from denser to again rarer medium? So one of the point I have told you, students, if you have remember, that when the light is going to move from the denser to rarer medium, okay, rarer means suppose it is air, completely here air is there, and this denser medium is any kind of a piece of a glass slab. Got it? When light is going to be moved from this denser to rarer medium, it's going to be move away from the normal. Suppose this is the imaginary line, okay, that normal we have taken, got it, represented by N, and it will just going to be moved away from the normal. This is the away from the normal. Got it? Now what happens when these light rays are going to be passed from rarer to denser? It is moving towards the normal, and when it is moving denser to rarer, it moves away from the normal. And these light rays do have the different name, as you have remember, I think so. So let me see those who have joined, whether you have remembered or not. Tell me, what is the name of this light ray which is going to be entered from the rarer to denser medium? Kindly comment and tell me that what is the name of this light ray which is going to be moved from the rarer to denser medium. Let me see how many of you are knowing. Still very few students have joined. I think they are not informed. Even for the short duration of time I have taken the class, that's why many of the students have not joined yet. It is a request to each and every student, kindly share it with your friends, make them aware that I am going to take the class. There is a quick revision of the class of the refraction of light. Got it? Because here my question is that what is the name of this light ray which is going to be incident at any kind of the denser medium? Is it audible to every student properly? Okay. Yeah, Vivek, Vikash, good afternoon. Now, you can see here that the name of this light ray is actually the incident ray. Incident ray, okay, and the light ray which is going to enter into the denser medium, जो light ray denser medium में enter कर जाता है, what is the name of that light ray? Because it is going to be refracted, so the name of this light ray we can say refracted ray, not reflected ray, refracted ray, okay, and the light ray which is going to be again come out from the denser medium to the rarer medium, that light ray is known as emergent ray. Okay, emergent ray. If you have remember, you can see there are three different kind of the light rays you are able to see here. The light ray which is going to be enter from the rarer to denser medium, which is going to be moved towards the normal, is known as the incident ray, and the light ray which is going to be refracted, which get bent completely, is known as refracted ray, and the light ray which are going to be comes out from the denser to rarer medium is known as emergent ray. Now there is a angle also which is formed. You can see here the angle which is formed between the incident ray and the normal. This is known as incidence. I am representing here with the symbol I. I is known as angle of incidence. I think it is visible to everyone. Angle of incidence, the angle which is formed between the incident ray and the normal, okay, that is known as incident ray. Yeah, thank you for wishing. Yeah, refracted ray, Satyam, very good. Now next you can see here the angle which is made by the refracted ray and the normal. You can see here this angle, that is known as refracted ray. We can see here this is not reflected ray, here it is known as refracted ray. Very good, Satyam. Refracted ray. And or you can, so wait, you can say here this is your refracted ray. This is angle of refraction which is made, the angle which is made by the refracted ray and the normal. The angle which is made by refracted ray and the normal, that angle is known as angle of refraction. Angle of refraction. Yeah. One more angle is there. The angle which is formed by the emergent ray and the normal, that is known as angle of emergence. This angle is known as angle of emergence. Angle of emergence. Okay. I hope so you are understanding that what happened with the light rays when it is moving from the rarer to denser medium. Okay, the speed of light is getting changed. You can imagine easily. Suppose you have you are just driving any kind of a bike. आप इसको ऐसा समझो. It's very easy to understand. Suppose you are driving any kind of the bike over here on the road, and that road is completely smooth and is very good like your highway. Okay. What happen if you will not get any kind of the traffic, you will move very fast at the normal speed, or you can move very fast. But what happen in the crowdy area? While you are going to be moved with a crowdy area, your speed is not going to get increased. It will be always getting slow. The same thing is happening, student, here also. In the denser medium, due to the high density, the molecules of the any kind of the substances which have the higher density, the molecules are very closely and tightly packed together. But in case of the rarer medium, like in air or any kind of the vacuum, what happens? The molecules are very loosely packed together. Okay. What happens? The same thing is going to be happening here also. When light rays is going to be passed through this medium, the speed is getting very high. Speed उस केस में बहुत ही ज़्यादा high होता है. But when it is passes through the any kind of the medium which have very high density, the speed of light is getting changed. That is getting very slow. Now you can imagine and you can tell me the answer on which medium the light ray will be just going to be moved slowest. सबसे कम कौन से medium में जो है light ray travel कर पाएगा? Kindly tell your answer. I'm just going to see in the comment section. Okay. In which medium, your question is, in which medium the light ray is going to be moved slowest? सबसे slow किस medium में light ray जो है बच्चों travel करेगा? Yeah. Let me get the answer. Okay. Yeah, if we are talking about the medium, it should be the solid medium. Okay. And the hardest substance which is transparent, that is known as diamond. Okay, so in the diamond, I hope so and I think so, the light rays should be slowest in that case. And if we are talking about the fastest, on which medium the light ray is going to be moved fastest, that should be air, or you can say vacuum. The best one is the vacuum. It is just taken as about 3 lakh km per second. The speed in the vacuum, it is taken as 3 lakh km per second, and there is a slight change while air is moving from the while light is moving from the vacuum to the air, because in air also molecules are very far apart from each other, so the speed of light is changing very slightly. Got it? Now, if you have understood these things, then you can just easily see and you can understand one more topic, that is known as refractive index. Let me just get how many of you have, those who have connected, kindly share this link with your friends, because I think they are unaware about it. I have just taken in a short duration of time. The class I have started in a short duration of time. I haven't shared to the much students. So those who are currently present here, kindly share this link with your friends so that they can come alive and they can understand about the topics, whatever the revision class I'm going to take here. वो सारे बच्चे सीख सके, समझ सके बच्चों, क्योंकि आपको मालूम होगा कि सबसे बड़ा और सबसे अच्छा इन्वेस्टमेंट जो है किसी भी चीज में अगर इंसान की होती है तो वो है नॉलेज. ठीक है, तो अभी अपने टाइम का इन्वेस्टमेंट आप यहाँ पे करो. जस्ट ग्रास्प द नॉलेज, रिवाइज योरसेल्फ एज मच एज यू कैन, एंड इन फ्यूचर be a very successful person or very bright student of your life. Okay, so there is a humble request from my heart that those who are present right now, kindly share this link with your friends so that they can also come live and their topic can be covered, or they can also revise for their board examinations. Okay, let me just see how many of you are just getting right now. Okay, so I hope you all have understood about the different types of rays, that while any kind of the rays is coming from the rarer to denser medium, that is known as incident ray, and the light ray which is going to be passed through the denser medium, that is known as refracted ray, and when the light ray is coming out from the denser to rarer medium, that is known as emergent ray. And how this is getting diverted, for that you must have to remember two statement. One statement is, when light is traveling from the rarer to denser medium, it is always move towards the normal. ये हमेशा ये सीधा चला जाता, but it is just bending towards the normal. ये normal की तरफ bend करेगा. And while light ray is moving from the denser to rarer medium, it is moving away from normal. ये अगर light ray सीधा आता तो ऐसे चला जाता, but it is just moving away from the normal. Got it? That light ray is known as emergent ray. There is three angles, as there is three different rays. First angle is known as angle of incidence, which is formed by the incident ray and the normal. By the incident ray and the normal. Okay? And the angle of refraction, with the help of refracted ray and the normal, this angle is formed. And angle of emergence by the emergent ray with the help of normal ray, it is forming angle of emergence. Got it? I hope so. Up to here, nobody have the confusion that how the light is going to be bent in case of any transparent medium, because the speed of light is getting changed while it is traveling from rarer to denser medium or denser to rarer medium. Okay, you can take lots of examples. You can see in our earth also the same phenomena is taking place. See, this is our earth, suppose, okay, and we do have the atmosphere, the layer of air around us. In our earth, हमारे earth के around में क्या है? Layer of air है, atmosphere present है. Now the sunlight which is coming from the sun is very far away from the earth, is very far away from the earth. Okay, so what happened? That light ray is just coming towards the earth's atmosphere. Here there is completely vacuum. The light is traveling very fast, around 3 lakh km per second. But as it is just going to be moved in the denser medium, in comparison to the vacuum, air is also a denser medium. But there is a slight change. That's why we are not taking it as way high in comparison to the glass or any kind of a solid or the liquid medium. Okay, so there is a slight change in the light rays, but it will also going to be come down on the earth's surface. Okay, so the speed of light in the vacuum or the air is very high, but it is less in any kind of the denser media in comparison to that. That is your glass or the water, any kind of the solid or the liquid, but solid should be transparent. Got it? So up to here, I don't think so you do have any confusion. Let's proceed towards the next topic of this chapter, that is known as refractive index. Okay. Now, before starting this topic that is known as refractive index, I just want many of the students right now, because very less students have joined here, because I have started my class without information or very less information of the student. So those who have joined right now, kindly share it with your friends. Okay, and let me see how many of you are just getting in. Okay, so students, as I told you, we are going to be moved towards our next topic, that is refractive index. But before starting that topic, let me recall you what was the laws of reflection. Okay, there was two laws of reflection that I have dictated in the last video also, and that two laws of reflection was, you can see here, one was angle of you can see here, one was, suppose if we are talking about the laws of reflection, then you should remember that incident ray, reflected ray and the normal at the point of incidence all lie at the in the same plane. Okay, Another one was angle of incidence was equals to the angle of reflection. There was two laws, but here what happened, the light ray is not going to be bounced back. Here the light is going to be passed through any kind of the medium. Okay, here the light ray is going to be passed from one medium to the another medium. Suppose this is denser medium, this is rarer medium. So whenever the light ray is going to become, this is known as incident ray, and since this is normal, okay, this is normal, so whenever light is just going to be passed through any denser medium, what happened, it is going to be bent towards the normal. So it will bend towards the normal. So this is refracted ray. So in between them there is two angles, you can see here. This is known as angle of incidence and this is known as angle of refraction. So here are two laws. The first one, it is saying that sine of angle I, sine of angle of incidence ray to the sine of angle of R, that is angle of refraction, that is always constant. That is always constant. Got it? Means that should be equals to K, we can say. So this is also known as Snell's law because the name of the scientist was Snell's, and he have actually given this idea about that how angle of incidence and how angle of refraction is related with each other. Got it? And another law was according to the same as you have seen in the angle of reflection, but there is a slight difference because here there are also three rays. You can see incident ray, refracted ray and the normal. You can see at the point of incidence, इसे भी यहाँ point of incidence कहा जा सकता है ना? Because the incident ray is going to be incident at this point on the surface. That's why it is also known as point of incidence. So again, incident ray, refracted ray and the normal at the point of incident, they all lie in the same plane. आप अगर यहाँ पे ध्यान से देखोगे तो एक plane surface दिखाई देगा. यहीं पे हमारा इंसिडेंट रे है, रिफ्रैक्टेड रे है और नॉर्मल इसी पॉइंट पे लाई कर रहा है, सेम पॉइंट पे. So here also only here we do have the reflected ray, but here you need to understand about the refracted ray. So these are the two different laws of angle of refraction which I have told you right now. If you have studied, even I have just taught in the classes also. This is the revision class. So we will go in a short duration of time. Another one, the main topic here which I was talking about, that is refractive index. Refractive index. Students, I have told you that refractive index is quite is nothing but is a ratio of sine of angle of I to the sine of angle of R. Means angle of incidence, that is sine of angle of incidence to the sine of angle of refraction. That's why before starting the refractive index I have explained you about the two laws of refraction. Got it? So here we will get the formula sine of angle of I, that is sine of angle of incidence to the sine of angle of R. Even the light ray is just having some speed also. So whenever any kind of the light ray is moving from the rarer to denser medium, okay, so we can say the refractive index having the another formula also based upon that. But before moving in that one, let me just give you one question. If you are live right now, can you try to give an answer related to your refractive index? And one more thing I'll tell you, that refractive index student, they doesn't have any kind of the unit. The reason behind that it doesn't have any kind of the unit because it is a ratio of angles. Both are going to be cancelled out. कभी भी किसी भी चीज का सेम यूनिट का रेशियो हो तो वो यूनिटलेस होता है. Okay, and it doesn't have any kind of the unit. Try one question to solve here right now. Yeah, thank you, Prince. Let me just give you one question. The help of refracted ray, that is a refractive index. Okay, just try to solve this question. Suppose here you do have, the question is, here, this is the formula through which you can just go through it. Here you do have the question that suppose angle of incidence is 60 degree and angle of refraction is 30 degree, then find out refractive index Let me see how many of you are able to just find out. I'm just waiting for your answer. Kindly do it. Yeah, thank you, Prince. Is it visible to everyone? Your question is, here the formula is also given. Refractive index is equal to sine of angle of incidence to the sine of angle of R, and here the angle of incidence is given and the angle of refraction is given. Kindly just find out. Let me see how many of you are able to give the answers. How many of you have remember?